Hello, hello, it's Gary. We're going to do some math. Here we go. All right, so the first question is a little review. That looks bigger than usual.
Yeah, I think it is.
Oh, I had no idea I could shrink it. Ha, learn something new every day. Okay, so the problem is right there, 6 sine of x to the power x. Okay, let's do it. So again, this is a review. Review chapter 3. And this is 3.9, number 17. We want to know if f of x equals 3 times the sine of x to the power x. What is f prime of x?
Don't hurt me.
Okay, so here, because I have a variable in the base and a variable in the power, I can either use the power rule or the exponential rule, so I have to use what's called logarithmic differentiation. Logarithmic differentiation means write it as y equals and then take the log, a log of both sides. The easiest log to take would be what?
1.
The natural log. So then we'll apply the natural log to each side. So we get natural log of y equals the natural log of 3 times the sine of x to the power x. Ooh, extra line there. Let's get rid of that. Like that. Now, I would like to pull the x out, but the problem is the 3 stands in the way.
No,
Can't divide by 3 because the 3 is inside.
natural log of 3 plus natural log.
Yeah, so natural log has multiple nice properties. So the property we're going to apply is if you have a log of a times b, that ends up being log of a plus the log of b. So logarithms, because they're exponents, split on powers to addition. Because a log is an exponent. So back here, new page. So that's going to give me the natural log of y equals the natural log of 8. 3. Somebody asked me about 8 last night. 3 plus, now I can go x times the natural log of the sine of x. Because I can pull that power out now that I've isolated the sine of x. And I can implicitly differentiate now. All right, so implicit differentiation, then the derivative of a natural log is 1 over. But the chain rule says I have to multiply by
dy dx.
dy dx or y prime, take your pick. I'm going to call it dy dx. Now, the natural log of 3 is just a constant. Derivative of a constant is 0. I'm going to write that in just for fun. Over here, I have to apply the product rule and the chain rule to do that one. So that one's a little funky. So I'm going to take the derivative of x first, which is 1, leave the other function alone. Then I leave the x alone, adding it on, and take the derivative of the natural log of the sine. What's the derivative? So what's the outer function there? The natural log, so it'd be 1 over. And then I have to multiply by the derivative of the sine x, which is cosine of x. All right, so cleaning that up just a little bit on the right side, I have the natural log of the sine of x plus x times cosine of x over sine of x. Now you could at this point choose to say, oh, cosine over sine, that's really the cotangent. Yeah, so you could rewrite it that way too, so that'd be another option. Or you could leave it as sines and cosines. I don't think it's a big deal. That's supposed to be an x. So that's another way you could write that. But I'm not quite done. I have to solve for dy dx. So next thing I would multiply by y. So that's going to give me dy dx equals y times, parentheses, natural log sine of x, oops, and I missed a parenthesis, plus x cotangent x.
And then you just put ln 3.
And then, so we're almost done. So usually we replace y with what it's equal to here. So y would be 3 sine of x to the x would be my final answer. So I'm going to put that on the next page, or I could just shrink all this a touch. I didn't catch everything. There's probably a select all. I'll check it out. There you go. One more try. Select all. Got it. All right. So then the final answer I would state as 3 times sine of x to the power x times all of that.
You have to plug into the number.
Oh, we have a number to plug into?
Yeah.
Oh, fun. All right, so that's the cleaned up derivative. Back to the original problem. Plug in 2, it says. Oh, and it had a 6, not a 3. Oh well.
Just change it 3 to a 6.
Yeah, you could just change the 3 to a 6, right? That would totally work. So why is it in review mode?
No,
sorry.
Confused.
Okay. Yeah, so then I would just plug in 2 everywhere and get a number. So I guess I can go to a calculator. So Desmos. So that's going to give me, let's see, they had a 6 times parentheses, the sine of 2, close parentheses, raise it to the second power, times the natural log of the sine of 2, parentheses, plus 2 cotangent of 2. Did I type that right? I think so. I got -5-ish. Anybody else?
Yes.
Got a -5. Okay, -5.01. I'm not sure how many decimal places they want. Oh, enter a mathematical expression. So I could have entered all of that in here just for fun. Let's try it for fun. 6 times, parentheses, the sine of 2 raised to the second times the natural log of the sine of, I guess I should blow this up.
Wait, aren't you plugging it in for F2? For
F prime of 2? Yeah.
Yeah.
2, close parentheses, close the log, add 2 times the cotangent of 2, close. And I didn't get any errors, right? If I didn't close a parenthesis, it's going to say, hey, syntax error, something's incomplete, unmatched parentheses. So always pay attention to those errors. And submit. Woo, I got it right.
Yay.
And they give the numerical answer here. That was exciting. All right, next. What should we do? 19? Again? So the answer to 19 is going to be whatever multiple you have there times parentheses the sech, the hyperbolic secant of whatever your multiple is of x, close parentheses, and then square it on the outside. If you try to square it on the inside, it'll flip out on you and give you an error message.
What are all of the, like, if it was sine, if it was cosine?
You don't need to know those for the test. Hyperbolic derivatives you do not need to know for the test. So I think we'll go over those later in the course.
Hyperbolic derivatives are just
And they're not exactly the same as the regular trig derivatives, but they're pretty darn close. I think the main difference is the Derivative of the hyperbolic cosine is the hyperbolic sine, not the opposite of the hyperbolic sine. I think that's the main difference. And they interestingly, the weird thing is they're all e to the x's, right? But there's similar identities and similar derivatives. Isn't it mind-blowing that sine and cosine can be similar to e to the x? Henry's like, holy crap.
Don't a lot of them just look like regular graphs? Like the hyperbolic cosine is just a parabola.
It's not a parabola. It's a shape called a catenary or a catenary, depending on where you're from. What's that, William? It's not a what?
Isn't it a hyperbola?
It's not a hyperbola either, but it's hyperbolic-like in that it has asymptotes, like a hyperbola does.
Wait, which one?
And that's why they're called hyperbolic trig functions, because they do resemble hyperbolas, but they aren't quite hyperbolas, but they're similar.
I'll do
Yeah.
13.
All right, on this same section?
Yeah.
13, see, I should submit, see if I get it right. Yeah, I get it right. But it didn't correct it because I'm the teacher and it's in review mode. 13, 3 times log base 6 of x. Certainly. There's two ways to do this one. So y equals 3 times log base 6 of x. One is to remember the formula, that the derivative with respect to x of log base b, any b, although b can't be negative or 0 or 1, is going to be the log base b, no, sorry, I got that wrong. Confusing that with another derivative. It's going to be 1 over
XL.
log base b, no,
Come on.
starting to act like it was yesterday. Apparently I'm still not over my quote. Natural log of b, there we go, is x. So that's the derivative formula for any log. So with that in mind, the 3 is just a constant. So the 3 just tags along. And then this would be 1 over natural log of 6 times x.
Got it.
If you wanted to separate out the constants, then you could say it's 3 over the natural log of 6 times 1 over x. Would be another way to express it. And that's it. What's that? You need to know this for the test, yeah.
Ooh, can you do it?
So here's the other way to do it. Hopefully you remember your properties of logarithms. And a property of logarithm you learned a long time ago is that log base b of x, there's the change of base formula, which is pick any log you want. Could be common log, could be natural log, could be anything else. So I'm going to use natural log. It's the natural log of x divided by the natural log of the old base. So for example, if you wanted to evaluate something like log base 2 of 8, your calculator does not have a log base 2 button, so you would enter natural log of 8 divided by natural log of 2. So everybody try that right now on the calculator, just as a refresher. Natural log of 8 over natural log of 2, you should get a very nice answer, the magic number. 3 is a magic number, right? You guys remember that song from Curious George? 3 is the magic number. No, you don't remember Curious George? You didn't watch that with your kids? Anyway, yeah, so this is 3. And the reason it's 3 is because 2 to the 3rd power is 8. Right?
Oh, and then you do it. Yeah.
Yeah, so if you converted that to a logarithm, an exponential statement, right, that you could get the answer that way too. But this is called the change of base formula. So if I apply the change of base formula, if I apply the change of base formula to log base 6, that's a 6, there you go, of x, then I'm taking the derivative of the natural log of x divided by the natural log of 6. Now, would you agree the natural log of 6 is just a constant?
Yeah.
So that means I can pull it out. So I could rewrite this as 1 over the natural log of 6 times the derivative with respect to x of the natural log of x. And what's the derivative of the natural log of x?
1 over x.
1 over x. So then I get that constant 1 over the natural log of 6 times 1 over x. right? And then if 3 was the other multiple, you just tacked the 3 down there. Okay. Questions on that one? Okay. Sam, what's up?
Can you do number 1 on the review assignment?
Number 1 on the review assignment, sure. And Dylan, if you have any questions, just let me know.
Okay.
So switching out of here to the review. Where is that? That's below chapter 3, right? There we go. Review. Number 1. Oh, I'm so glad you asked about that. I was hoping somebody would ask about the definition of the derivative. So if this appears on the test, I'm not going to ask for the step-by-step. I'm just going to say use the definition. And then you can do it any way you want. So you want each of the steps though, right?
Mm-hmm.
Here? Okay.
Yeah.
So we have f of x equals 2 over x. There we go. So we have f of x equals 2 over x. We want to use the definition of the derivative. Oops, extra f there. So we're just going to state it. So I highly recommend the first thing you do in a problem like this is write the definition if I don't give it to you. H goes to 0, f of x plus h, minus f of x, all over h. And my steps are 1, 2, 3, and 4. So step 1. Replace the x with a blank parentheses everywhere there's an x, and then go and fill in those blank parentheses with x plus h. So I'm done with part 1. There's nothing I can do to simplify that fraction. So on the computer, I would just say 2 over x plus h. And I guess on the computer, you need the parentheses to do that, for it to appear right. Step 2, then from that, subtract f of x. So f of x plus h minus f of x equals, just take whatever you got before, 2 over x plus h, and subtract the original function, 2 over x. Now here we've got to do some simplification. I have 2 fractions to subtract. I need a common denominator. Since x plus h doesn't factor, the common denominator is going to be x times x plus h. So this one needs a multiple of x, top and bottom. This one needs a multiple of x plus h, it's top and bottom. So that gives me 2x minus, now here's where I have to be extra careful. Not only am I distributing that 2 through there, but I'm also distributing what? Yeah, the negative has to go with it. So that's going to be negative 2x minus 2h. And I'd recommend not multiplying out the bottom, but you can if you want. Your choice. Cleaning that up, I have like terms in the top, so I get negative 2h over x times x plus h. So that's what I would answer for step 2. And does anybody know why there's a 2 in the top here?
There's a 2 on the
Because there's a 2 in the top of the original problem. All right, step 3 is to divide by h. So in step 3, I've got negative 2h over x times x plus h. And I need to divide all of that by h. Better way to divide by h is to do what here? Multiply by the reciprocal. So negative 2h over x times x plus h. The reciprocal of h is 1 over h. And so then I can see here that h divided by h is going to cancel out because the number divided by itself is 1. So step 3, I get negative 2 over x plus h times x. Now, finally, for step 4, I can take the limit. And on the test, I would very much appreciate it if you would write LIM, h goes to 0, state where you're taking the limit of, let h go to 0, which we can more concisely write as negative 2 over x squared. So that would be the final thing to type in. Not bad.
So we did a lot.
What's that?
We did a lot of that from the beginning.
Yeah, so I'm just making sure you still remember that because it's going to be on the final exam. So I just want to make sure people are still remembering it. Now on the test, if that problem appears, I'm just going to say use the limit definition, which means you have two options, right? One limit definition is the one we just did, as h goes to 0. That's an arrow. F of x, oops, I have all kinds of writing difficulties. X plus h minus f of x over h. Does anybody remember the other definition?
Isn't that limit of x to b?
Yes. The limit, and usually we let b go to x, but you could go either direction, doesn't matter. And then I would say f of x minus f of b over x minus b. If you switch the limit with x and b in the first part, then you get an f prime of b in the end, which is no big deal. But here we usually want to call it f prime of x. And sometimes that way is easier. It just kind of depends on the problem. So you could take either one. So that other problem I just did would look like this. B is going to x. I would have 2 over x minus 2 over b all over x minus b. Common denominator for the top would be what?
XB.
xb, so I'd have to multiply by a b there and an x there. So I get 2b minus 2x over xb, and all of that is over x minus b. You could factor what out of the top?
2.
A 2 or a negative 2. You go either way. If I factored a 2 out, switch colors, then I would get 2 times b minus x over xb. And what's another way of dividing by something? By the reciprocal, so I could write it that way. And then does anybody remember the relationship between these two things? They're opposites, yeah. They give me a -1 instead of a 1. So then this simplifies to -2 over xb.
And that's.
Then we can finally take the limit as b goes to x. And can you see that we get the same answer? Yeah. And it's about the same difficulty in this case, I think, unless the x plus h freaks you out. But again, you have an option. So I'd recommend when you practice, try both methods and see which one you're better at and stick with that for the test. You may already know which method you're better at. All right, what else do you want to do?
Number 28 on the review side.
28 on the review. All right. Did you notice there were 32 questions? Anybody know anything nice about 32 as a number?
It's 4 cubed right now.
Or yeah, yeah. So it's a power of 2, which I always thought powers of 2 are cool. And I was in a hotel the other day, and I almost got to be in room 1024, which is the 10th power of 2, and I was on the 10th floor. It's like, oh man, but I was in room 1022 instead. All right. Anyway, numbers are interesting if you stop and look. How's it going? All done? Very good question. You do.
I can't remember.
You're just going to write something down. You cannot leave it blank. It's illegal.
I'll say something.
Yes. If you leave it blank, then you get a 0 on the whole test.
What's the word something?
No, write something mathematical. You totally got this. Make a guess. I bet you have a great guess.
Uh-oh.
What?
He doesn't know how to do a question.
That's okay. I don't know how to do things sometimes. All right, so we want to use logarithmic differentiation on this sucker here. All right, sir. Okay. And we got name on there. work there. Okay, moving on. So the first step in logarithmic differentiation is to write it as y equals. So I'm going to rewrite this as y equals x to the power 8x. Now I'm ready to take the natural log of each side. Natural log of y equals the natural log of, oops, wrong thing, x to the 8x. And what does the logarithm help me do here?
Pull out the 8x.
Curl out that 8x, helps me bring that down. So the right side becomes 8x times the natural log of x. And now I'm ready to take derivatives of each side. So then we implicitly differentiate. What happens on the left side? I get y prime over y. Yep. That's always going to happen on the left side. On the right side, we've got to use the product rule. So derivative of 8x is what? 8 times the other function, natural log of x. Plus, we leave the 8x alone, and then we take the derivative of the natural log, which is over x. And then we clean it up. All right, did you answer everything? Yes. Okay. All right, we got a name, we got a date. That's good, because I forgot to tell you, you get points if you get your name and the date right.
Could you?
Yes, you do. It's kind of a bonus. All right, so then what happens here? The x over x cancels, right? So that's kind of nice. So new page, I get y prime over y equals 8 natural log of x plus 8x. Is that right? No, just 8, right? Just 8, yeah. I can multiply y to the other side. Yeah, so if you guys finished, you're free to go. You don't have to hang out. You just want to see some more?
Yes.
Okay. And then I just have to remember what y is, and y was x to the power 8x. So I just plug that back in. And you could leave it like that or factor out the 8. That doesn't make that much of a difference.
Can you go back to that?
Yeah.
Yes.
I lost it somewhere.
Okay.
Nice.
8x, oh, times 1x, okay.
Yeah, because this is a 1 over x there. It's a 1.
I didn't see that.
So that's the derivative of the natural log. Yeah, so I had to do the product rule there.
Did you get y prime of y? That would sound really stupid.
Yes, good question. So if we focus on the derivative of the natural log, what's the derivative of a natural log? 1 over the thing. And then the chain rule says you have to multiply by the derivative of what was inside. Right? So then this can be rewritten as y prime over y. Yeah, good question. Better? Yeah. All right. Other things we want to go over. Wow, you guys are all speedy quick. And you answered,
rest of the review?
answered everything. No, you can leave if you wish.
Sweet.
All right. What else do we want to do? Any suggestions? Problems on the review or the sample exam?
Yes, there's one there.
Number what?
It's number
9. On the review
9.9.
in 3.9?
Yeah.
Oh, okay. So let's leave here.
I thought it was wait, no, no,
No?
that's mine.
Never mind.
Yes, I already did those.
Okay. So let's take a look at the sample exam.
Oh, yeah.
Let's see. I think the first page is pretty straightforward. We just did a problem like this one right here. We just then plug in the number after. On the real test, I wouldn't give you all of these steps. You would need to fill them in on your own.
Wait, so you take h goes to 0 and then you plug in the -2?
Correct. That's one. Well, that's the way I would do it based on the work we just did.
Okay.
Or you could follow those steps. That's another way to do it. Let's see if we can get the quotient rule right. And then we'll see what else we can do. We have about 10 more minutes. Let's see, quotient rule, I had x squared plus 1 over x plus 1. Derivative with respect to x and x squared plus 1 over x plus 1. So anyone that tried to cancel stuff ahead of time here, this does not, nothing here cancels.
Yeah.
X squared plus 1 is not factorable with real numbers. If it was x squared minus 1, that'd be a different story. Okay, but it's not. So I have to use the quotient rule on this one. So derivative of the quotient rules is low d high. So low is x plus 1. What's d high?
2x.
2x. Minus high, x squared plus 1 times d low. So it's low, d low, 1. All over low squared. And don't forget to write that down right away. Every once in a while I get excited and forget to write that down right away. And then I have only a numerator. That's a problem. All right, so let's see. We have a little bit of distribution in both pieces here. And then I have to distribute the negative. So let's see. That's going to give me 2x squared plus 2x minus x squared minus 1 all over x plus 1 squared. Only one pair of like terms in the top. So it looks like the next step would be to say that this is x squared plus 2x minus 1 all over x plus 1 squared. And let's see, x squared plus 2x minus 1 does not factor. So I'm done. Nothing cancels. We just had that one pair of like terms.
Okay, so on the test, you know how like in my open math they take an unsimplified answer?
Yeah.
You'll take unsimplified answers, or do you want it down to them?
I want you to simplify it as much as you can.
Okay, when you mean as much as you can, like to our personal ability, or like
That's not very
actually as
hard.
much as you can?
Actually, as much as you can. So if I see that it can be simplified in a nice way, then you wouldn't get full credit.
In a nice way.
So for example, if you left the answer as this, I
Oh,
wouldn't give you full credit.
well, yeah.
If you left the answer as this, I wouldn't get you full credit.
But
But if it was some crazy trig thing where it wasn't obvious what to do because you needed some identities, I don't think that would be such a big deal. Okay. On the other hand, let's see some other examples of things that came up. Yesterday when we were playing, we had something like, e to the 2x times e to the negative 2x. That can be cleaned up dramatically because the negative exponent means flip it. So that would be e to the 2x over e to the 2x, which is really 1. Yeah. So I'd hope you see something like that. Yeah. So
Is it like secant of x times cosine of x would just be 1, right?
so I write that
Yes.
down. So secant of x times the cosine of x, because secant is 1 over cosine of x.
And that's cosine over 1 and everything.
Then this would be cosine over cosine. So that would be 1 as long as cosine isn't 0. So it's kind of equal to 1, mostly.
so if we simplify it to that.
Yes, I'd be happy with you.
Okay.
All right. Any other suggestions on problems we should do here?
Let's do that graph one.
Yeah.
Okay.
Is that
I can't answer that question. The question was, is that going to be on the test?
And we'll tell you this, Vitor. Last time on the last practice exam, there was one on the graph, and you did have the graph on the side.
Yeah, and my major complaint about people's work on that one is your graphs were rather sloppy. So if there's a
Yours gave me a
graph on the
question
test,
mark.
please be neater.
I thought
Well,
it
hey,
was-
well, I'm not.
If you need a ruler, ask somebody or fold a piece of paper in half.
I'm not good at drawing.
You just put a question mark next
You
to
just
mine.
need to be careful. Okay, so we have 3 over x equals negative 2.
What?
All right. So f of x equals 3 over x, we ultimately want a tangent at x equals -2. So first thing I ask for is what is f prime of x? So we want the derivative with respect to x of 3 over x. And some people may have that derivative memorized, other people need to rewrite it in terms of a power. So I'm going to do that next. All right, so what is the derivative of that?
Negative 3x, negative squared.
Yeah, drop the power by 1. So it'd be -3x to the -2, which you could choose to write as -3 over x squared if you wish, or leave it with the negative power. Your choice. Next step, I said, okay, what happens when you plug in -2 into that? So that's going to give me -3 over -2 squared, which is -3/4. Right, because -2 times -2 is +4. So this was part A. This was part B. Part C was to actually give me the tangent line. So that means I need to know the y value. How do I find the y value? Well, I just plug in whatever x value I was given. Okay. So if x is -2, y is going to be -3/2.
3.
Yeah. And you could do it in decimals if you wish. I'm going to stick with fractions. So point slope formula, y minus y1 equals m times x minus x1. On a test, I would recommend writing that formula down. Anybody know why?
Because you need to show why you're doing it.
That's one reason. The other thing is to free your brain and make sure things are happening correctly. So what's the most common thing to mess up here? Anybody want to guess? You might switch x and y. The other thing is signs. You might mess a sign up, right? Because you have minuses here. If there's minus numbers to plug into, then shit could go wrong. So here, I carefully go y minus -3/2 equals m negative, lots of negatives flying around here, x minus parentheses -2. Oops. So then we just carefully evaluate all of those negatives. And I believe whoa, my pen is totally spazzing out. Carefully evaluate those negatives, and I think you'll get for a tangent line y plus 3/2. I'm stuck with the -3/4 as the slope, but I get x plus 2. You don't need to solve that for y unless you have a TI calculator that you want to check it on. But I would certainly plug this into my calculator next to help me do a good graph. So calculator, got that? So carefully plugging in. Let's clear that out. So let's see, I want to graph f of x equals 3 over x. And I want to establish the points -2, f of -2. And then I can go and find that point and check. Did I get the right y value? -1.5. I said it was -3/2. They're the same number, so that's cool. And then I want to type my y plus 3/2 or 1.5 if you like. Equals -3/4 or -0.75 if you like, x plus 2. And hey, that looks nice. On the paper, I think I said, hey, make a nice graph of this as x goes from 0 to 4, because that puts x equals 0 to -4, because that puts x equals -2 right in the middle. So points of interest for me are I want a couple of points on this curve to make a nice graph, and I might want those intercepts to make sure I'm getting the right line.
So do you have an issue if we convert like fractions to decimals?
The only time I have an issue is like if you have to plug in a number again and it's something like 1/3 or 1/6 or 1/7, rounding can cause some trouble. So if you have halves and quarters, decimals are great. But if it's thirds and sixths, decimals can be a little problem. Yeah, so just use your own judgment and be careful.
Oh, it's 50.
So then it's time to quit. Oh, we're time to quit. Yeah, so again, to do a nice graph here, get a few points to graph the line neatly, get at least a few points to graph the curve neatly, label some numbers on your graph. You all saw what my sample graph looked like on the sample test, on the last test?
Yeah.
Right? And I'm not the neatest person. That's an okay graph. I did pretty good. But that should be a good model if you're not sure what your graph should look like. All right, so study up. If you have any questions over the weekend, message your instructor or post it to the forum, even better, so that other people can, because other people probably have the same questions you do. If you see a forum question, try to answer it before I do. I'll give the forum questions like 24 hours before I chime in to give someone else a chance to get extra credit.
Are you gonna be here at all during the weekend or no?
Well,
You're here.
I won't be on campus, but I'll be in town, and I check my email a couple times a day.
Oh, okay, no, I was just wondering, like, if we wanted to, if we could come in and take it on, like, Saturday or Sunday while it's still fresh in your head.
No, sorry, I'm not going to give tests on Saturday or Sunday.
But
But it doesn't hurt to ask.
I'm probably gonna come in at 6 or 7 on Monday. So
Okay.
I'm
Oof,
gonna-
same.
Yeah, so Monday I will be in this building from 9 in the morning until 5 at night. So just a heads up when you're coming would be a good idea, and you're gonna take it in the Grand, right?
Yeah.
I'm gonna double check that it's in the Grand for you.
Okay.
And you should call them to make sure they're open when you want to be there,
Okay,
okay? Just to make sure.
all right, thank you.
Want to introduce me to the lady?
Sure, oh yes. All right, Dylan, we'll catch you later.
See ya.